In match problem 4, we came up with this derivative, 8 minus 4x. So now we want to assume we're starting with that same function that we started with, 8x minus 2x squared, which led us to this derivative, to answer a few questions. We want to find the slope of the graph of our function at x equals 1, x equals 2, x equals 4. So to find the slope of our function, we want to find the slope of our tangent line. All of those things meaning we want to take our derivative, 8 minus 4x, and evaluate it at each of these different values for x. So for instance, we'll start off by evaluating f prime of 1 is going to give us 8 minus 4 times 1, or 4. F prime of 2 will give us 8 minus 4 times 2, or 0. And f prime of 4 will give us 8 minus 4 times 4, which is negative 8. So we can plug numbers into functions, come up with these results, but we want to take some time to pay attention to what these different results mean. And that's what part B is asking us to do. So it's asking us to graph the function, then use the slopes from part A to make a rough sketch for the lines tangent to the graph at those different points. So this is our function f of x, 8x minus 2x squared. What we want to do is take these results from part A to sketch a tangent line to show us what's happening, what's the rate of change of our function at those different points. So let's start with f of 1. At f of 1, we came up with a slope for our tangent line of 4. So the slope of our line passing through f of 1 looks something like that, something increasing at a modest rate. Positive slopes in the line is increasing, showing that at this exact moment, our function is increasing. The function values are getting larger and larger. At f of 2, our derivative gave us a value of 0. So what that's indicating is that our tangent line is horizontal at x equals 2. So if we have a slope of 0, we have a horizontal line. So at x equals 2, the slope of our function is 0. At that exact instant, it isn't increasing or decreasing. A little bit before it was increasing, a little bit after it was decreasing, but at this point itself, the function is neither increasing nor decreasing. And then we can look at x equals 4. So here we came up with a slope of negative 8. So what that's telling us is that our tangent line is decreasing. The slope of that tangent line is negative 8, meaning that at that exact instant, our function is decreasing at that rate of negative 8.